Hi, my name is Benjamin Stewart, and today I'm going to be presenting to you guys the important prefixes in the metric system and how it's applicable to you. The metric system is an internationally recognized numerical system used to determine size and length, weight, or mass. It's a decimal system that helps you track the size and scale of things used in that system. The standard units of measurements are MKS, which stands for meters, kilos, and seconds. There are 20 recognized prefixes of the metric system, all of which have a variable of 10, which you'll see to the chart on your right. The metric prefixes are based on units acknowledged by the International System of Units. Everything within the metric unit of measurement is based on a unit base of 10. Using that logic, as you go up and down the chain, you can see things grow and change through that power of 10. An example of this would be hecto, which always represents 10 to the second, as 100. Deca, which always represents 10 to the first, which is 10. And deci, which you see here, is 10 to the negative 1. Here you see what we call a metric prefix chart. This is easily used to understand the symbol prefix as well as what the multiplication factor of that said prefix would be as you can move up and down the chart. You'll see here that it's broken into halves, a top half and a bottom half. As you can read the prefix, deca, hecto, kilo, mega, giga, tera, peta, and eka for E, you'll see that it goes all the way up, 10 to the first, second, third, and henceforth, and it goes down. These prefixes determine whether it's 10 to the negative first, 10 to the second, and therefore the decimal spot. Deca, or deca, is the first unit prefix moving up in the larger scale. Its value is 10 and is equal to 10 to the first, and its symbol is DA. Hecto is the second unit prefix moving up the scale, and its value is 100. It is equal to 10 to the second, and its symbol is H. Kilo is the third unit prefix moving up the scale, and its value is 1000. It is equal to 10 to the third, and its prefix symbol is K. Listed below are examples of using that prefix, deca, kilo, and hecto, and then subjugating in the meter, which is the length measurement. By using deca, you know it's always 10. So 1 decameter equals 10 meters. 1 kilometer equals 1,000 meters. Hecto means 100, which will mean it's 100 meters. Mega is the fourth unit moving up the scale and is equal to 1 million. This is represented by 10 to the 6th, and its metric prefix symbol is M. Giga is the fifth unit moving up the scale and is equal to 1 billion. It is represented by 10 to the 9th, and its metric prefix symbol is G. Tera is the sixth unit moving up the scale and is equal to 1 trillion and is represented by 10 to the 12th with the prefix symbol T. Same idea, such as mega, which always means 1 million. Therefore, 1 meter, which is used as 1 megameter, will always mean 1 million meters. It's a little confusing, but once you understand what the prefix means, you'll automatically be able to understand what that length measurement is when used with the prefix. Such as 1 terameter will always be 1 trillion meters, since the base unit is 1 times tera, which is a trillion. Peta is represented by 10 to the 15th and has the prefix symbol P. It is equal to 1 quadrillion. Exa is represented by 10 to the 18th and has the prefix symbol E. It equals 1 quintillion. Zeta and iota are not represented in most charts available, but are 2 spots above the original 8 that are represented by prefix symbols Z and Y. They are hardly ever used, but are written in scientific notation 10 to the 21st and 10 to the 24th. Hope that you don't really have to use these. Here what we have is the prefix symbol chart that's going up. So like I said, it was broken into 2 halves. So now you can use the prefix, such as mega, which is always a million, subjugated in with its symbol and its numerical value. So 1 megameter, meter being the base value, mega being the prefix, would be 1 million. As we go down the chain, you can see that these are represented on the other side of that chart in smaller values. Deci is equal to 10 to the negative first, which has a value of 0.1 in the 10th place. They can go in order just as they went up in order from the previous set of slides. So as we went up before, now we're going down. These also follow the same rule as the previous prefixes and fall in the order of nano, which is 10 to the negative 9th, and equals the billionth place, pico, which is 10 to the negative 12th and equals the trillionth place, and femto, which is 10 to the negative 15th and equals the quadrillionth place, atto, 10 to the negative 18th. The metric prefix symbol for all of these are N, P, F, and A. Similarly to zeta and yada, these prefixes zepto and yocto are on the 9th and the 10th places on the chart. Only in certain circumstances are these used to describe the very small quantities or subunits. They are represented as prefix symbols Z and Y and have the scientific notation of 10 to the negative 21st. It is the sextillionth place in its decimal form. The Y for yocto is represented for the scientific notation 10 to the negative 24th and is the septillionth place in decimal form. Why does this matter and when does it apply to me? Here in the United States, the use of the metric system is not as large a priority as every other part of the world, but it is important to understand its system for use in math, building, and other parts of everyday life. The metric system is largely viewed as the more logical system due to the simplicity of the form of base units of 10. Everyone will be faced with a metric prefix at some point, so pay attention. Thank you guys, and I hope you enjoyed my presentation.